So I'll be basically walking through 2 weeks of the workout Wednesday that I have been working on. The first step is forecasting and anomaly detection. How it works is, so firstly, the data set that I'm using, if you remember, the last time I had this I had made this matrix with conditional formatting. So the data set I used is the ice coverage on some of the lakes over the years. So we'll basically be using the same data set. Initially, let me just open up the data set I had, because I made some changes in Power Query editor. The initial set I had was there was a column of year, and then there were like 5 different lakes, and what is the coverage of those lakes in that particular year. I had to modify it as the very first step. So how I modified it is like this. Yeah, so you can see that I have one column of year, one column with the different names of the lakes, and then the third column is coverage. So this was basically the first step. Now talking about what my objective is for forecasting. First of all, this basically will help me get an estimation of what the data should be after a particular time interval. So this will be for forecasting. And anomaly detection is, I would like to understand, like based on the data we have, I'll make a trend, and I like to know that if any of the particular, like the actual data we have, how different is it from the one we predicted. So this is basically anomaly detection. How I'm going to walk through this is, okay, let me just first, yeah. So one thing to know about this is it only works on line chart, and this I have in here. So my x-axis will have year, and the y-axis will have coverage. So this is basically the line chart I have over the years. The years start from 1973 till 2020. And now I want to know that, say suppose I want to forecast for the next 10 years, that is until 2030. So we have a direct approach to this, where we just have to switch on the forecast, and we have a good estimation of what it should be till 2030. If you'll notice in the objective, we have this line. This is basically a trend line. Again, I can just switch it on, and then we have the trend line. The forecast, like for the amount of years I want to have forecast for, it can change. It's 10 right now. That means from 2020 to 2030, but it can change with whatever changes we want. So this is the simple forecasting method. There's another thing which is more interesting, which is the anomaly detection. Before that, let me just add a slicer. So what we'll have is, we'll have the which particular lake I want. Yeah. So I can change whichever lake I want to have. You can see that here on will have a different forecasting, and similarly Airy will have a different one. So yeah, that can work. Anomaly prediction is much more interesting. So let me just this will throw an error for the for the first point. So I'm taking year, and on the y-axis I am having coverage, and this is the exact graph we got before we started forecasting. So if I try to switch on the anomaly, it's not an active option, primarily because for this we need a date time value, as you can see as I'm hovering over. So it requires a date time value. The problem with the data I have is the year is in whole number, and I can't just switch it to date, because see, it's 1973, the least year we have, and if I directly switch it to date, it actually gets a little it's wrong. Like it shows us some different values which wasn't exactly what we wanted. So I'll change it back to whole number. And there are multiple ways when I can get the year function. I can make a new table and stuff like that, but for this part, I'll just add a new column, and I'll use the simple date function. So say suppose year date time is the name of the column, and I'll use the simple date function where I'll have the year as the year we have for the table, month will be 12, and day will be 30. So we'll get this date and time for function. I don't exactly want this format. All I want is the year. So we have the year. So now we have the year in the datetime function exactly how we want it. Now I can use it. So I will remove the year I used before and I'll use this one. Yeah. I don't want hierarchy. I just want the year. Yeah. So we have this. And now if we'll go to the anomaly function, it will work now. Yeah. Now, in anomaly in itself, there are different properties or settings we can change. It's customizable. I'll explain what that means, but let me just start before. Add a second line chart that also displays average coverage and 70% sensitivity. What sensitivity means is the higher you add in your sensitivity, the more let's just use the command of like the more sensitive it is to the data, means we'll have more anomalies than before. So if I'll just change, you can see that the by default sensitivity is 70%. If I apply it as 75% and then apply, it's not changing, but say suppose should change by 85. Okay. Yeah, well, if I reduce the sensitivity, the number of anomalies we had is changed. Right now we have 5, but say if I take the original one, which was 75, then it increases, right? These weren't before. So the black dots we have, this basically tells us that the coverage here is 80.4 and it's very low because the expected was 398.69 with the they have also mentioned the minimum and maximum value. Another very important feature in this is if I'll just click in here, then I can actually have the explanation of why this is an anomaly. And so this is an error in the Power BI right now. I tried going through like how I can change it, but as you can see, it appears that this feature is currently bugged. I'm not sure why this is happening, but it usually shows the reason why this anomaly is. So it basically shows us which particular lake might be causing this problem. So this was basically it. Yeah, there's one more thing. So if I click on it and it gives me an explanation, there is also an option where I can add it to the report. Add it to the report means I can add what possible explanation it is in the report in itself. If I click that, there is it automatically gives us a text box in here which shows which basically has the explanation we saw or earlier. We can change that text and modify it, remove the stuff we do not want and add stuff we want accordingly. So this is basically week 9. The next part is week 10, which is a Violin plot custom visual. This is something that I found very interesting when I have a lot of data and I want to analyze it on the basis of statistics. Violin plot is basically a combination of a kernel density plot and a box plot. So kernel density is basically the normal density function we used to have. It's a smooth out histogram in a very simple definition. So let me just first create it. So I think it will be easier. I did not have Violin plot by myself, so I had to import it from here. Like if I select get more visuals, it will basically open up a new tab and I can just select it. So I can add it from in here. I did that. Now I have this Violin plot and I'll add the data. So for the sampling, I wanted to do it by date. For measure data, I have average temperature in Fahrenheit and I want to categorize it by month. So we have this data. Now, what this basically is showing us is a kernel density plot. This blue part is the density part, and this is a box plot. So we can change a box plot the way we want. Box plot basically gives us a median value and a lower and higher quartile range. Lower and higher quartile range, I think the simplest way I found is this one. This basically means first quartile basically means 25% of the data we have is less than this particular value, and third quartile basically means that 75% of the value is less than this. Means 25% of the value, 25% of the data falls has a value greater than this particular value. So the middle part we have, this is called interquartile range. This basically gives us the area where we have maximum probability of finding a data. These are the minimum part. They fall outside the interquartile range. So box plot basically gives us that. If we have a box, you can see that okay, so the circle here is the mean part, but the white line, that's median, and we have a lower quartile range and a higher quartile range. The challenge I had in the workout by Wednesday that basically wanted me to change it to barcode strip. I can show that in here. Let me just take it there. So use the barcode strip plot to show the individual temperature values. If you do not want a box plot in here, that can be changed. I just need to go through Violin options. No, it's not an option. Oh no, combo plot. Yes. So instead of box plot, I can have barcode strip. So it basically works like that. I can change the color, obviously, the way I want, and it can work like that. I'll just keep it as box for now. So this gives me the data. This gives me a statistical way of viewing the data as to how far we have the median and mean, and it, as you can see, it also shows the standard deviation, meaning how broadly is the data spread throughout, like how broadly is the data set for one particular month. If I take you back to this, one of the things that I had to do is identify the months with highest and lowest standard deviation. So as you can see, it also gives me the standard deviation. We can see that October is the one which has the highest one, obviously, and I think the lowest would be in July because it's 3.98, and I don't think there is anyone smaller than that. So yeah, this is basically how we have the Violin plot. There are a couple of more settings that I'm not exactly sure of how this goes. Like they wanted me to have a sampling resolution as high. I think this basically means that how, okay, I'm not sure about how that sampling resolution works, but yeah, this is a couple of ways in which we can change the Violin. Yes, I guess that is all I had.